Jai Hind to all. Myself Dr. Santosh Kumar Upadhyay, Associate Professor in CSC Department in AKGEC Ghaziabad. Dear, today I am here to discuss very important topic of computer network, that is the IPV4 addressing. In previous lecture I have covered what is the length of this IPv4 address, that means IP address, and what are the different kind of representation that we can use. So if I recall all these, so I can say that there are the three kind of representation: binary representation of IP address, dotted decimal notation, and the hexadecimal notation. Okay. So now in this class I will cover the topic and the matter that is related to the IPv4 addressing. Okay. So basically this IPv4 addressing, as we know, the 32-bit long, but there is a 5 kind of classes given here. 5 kinds of class group are there. Huh? That is known as the classful addressing, known as classful addressing. Classful addressing. Classful, because this 32-bit means this IP address is divided into 5 different classes. Okay. So let us see. In classful addressing, the addresses space is divided into 5 classes known as the A class, B class, class C, class D, and class E. So let us see what are these classes. So these are the representation of all the classes: class A, class B, class C, class D, class E. As I have already told that there is a 32-bit long IP address. That means 4 bytes are there. First byte, second byte, third byte, and fourth byte. Okay. So this is the class A address. Class A, in this first byte is kept for network ID, network ID, and remaining 3 byte for host ID. Host ID, 8-bit for network ID, and remaining 3 bytes are for the host ID. So as you know that by using 8-bit 2 power 8 total network can be designed. How many network? This may be simple question. By using class A, what is the number of network that you can design? What are the different number of network that you can design in class A? So as we know that in class A addressing, first byte is for network ID and remaining for host ID. So first byte means by using 8-bit we can design 2 power 8 different network. Okay. And the size of each network will be 2 to power 24, means 2 power n, this is the host ID, 2 power n, this is the network ID, then 2 power 32 minus n, this will be host ID. This is net ID, and this is for remaining bit for host ID. Host ID. Am I right? That means in class A address, network space is very large. That means number of network is low, means small, but their size is large, because each network is capable of keeping or of having how many computing device? 2 to power 30 to 2 power 24 devices may be assigned in single network by using class A. Now, next is class B. In class B addressing, first byte and second byte, these 2 bytes colored in yellow color, these 2 bytes are reserved for the network ID, and remaining 2 bytes, this is the white color, no color, this is for host ID. Okay. Similarly, in class C, first 3 bytes are reserved for the network ID, yellow color, and the remaining 1 byte only used for the host ID. Okay. 3 bytes for network ID means what will be the different kind of network? 2 to power 24 networks can be designed. 2 to power 34 networks can be designed. 2 to power 30, 2 to power 24. And each network, the size of each network will be maximum 2 to power 8. 2 to power 8. Okay. Basically 2 to power 8 minus 2 you can say. First one for the network ID and last for the this is 2 power 8 for size of the network. Now the class D for the multicasting. Okay. Class D is used for the multicasting purpose and class E for the reserved for the future purpose, like that. So these are the 4 classes, 5 classes in IPV4 addressing. Okay. You should remember one thing, that what is the number of bit used in network ID and what is the number of bit used for the host ID in different classes. If we talk about the class C, then you should remember that there are the 3 bytes, first 3 bytes for the network ID and remaining 1 byte for the host ID. Okay. Again, there are the very important question that come from this all the 5 classes. You have given a particular sample of IP address. Now they will ask in which class this address belong. Okay. That means you have given a particular IP address and they ask, let me know, or please give the class which this address belong. For that, there are some trick that you should remember here. Okay. So first, you know that this is the first byte now. So by using the 8 bit, first byte means 8 bit. What are the different kind of number that can be generated? So you can generate 2 to power 8 different kind of number. Okay. Ranging from 0 to 127. 0 to 2 to power 8 minus 1. 0 to 127. Okay. So this is the 0 to 127 different kind of number in first byte that may arise here. Okay. And for class B, next from 128 to 191, this number for the first byte will be reserved. Then for the class C, next 192 to 223 will be reserved. That should be remembered by you. Okay. Again for 224 to 239, this is the class D for the first byte, and 240 to 255 for class E. Okay. So if you have clear idea about this number, so by looking the dotted decimal notation, you can easily find out which class this address belong. Suppose I will give you an example. Suppose a dotted decimal notation is given like, let me remove that now. Yes, 1 minute. So let us see here. Let us take an example. Okay, IP address is given and they will ask, yes, please tell me the class of this address. Suppose you have given 200.11.32.64. The sample of this IP address is given and they will ask, please tell me what is the class of this IP address. So if you have clear idea about this one, 0 to 127 class A, 128 to 191 class B, 192 to 223 class C, class D similarly 240 to 255 class E. This is the range of the values that come in the first byte. Okay, so here you have to check only first byte of the dotted decimal. By looking this number, decimal number, you can easily find out which class this belong. This is the 200. So where this belong? 0 to 127? No, that not belong under this range. 128 to 191? No, this is the 200. More than 191? Not belong in this. Again, 200 belong into 192 to 223. Okay, in this range, this number lies. That means this address belong to class C address, basically. Class C address. Okay, that's why this number is very important. So if dotted decimal is given, so you should have idea about this one. Okay, and if binary address is given, then you should have clear idea about this. So first one, this class A address always belong to start from first bit as 0 in the first byte, first bit of the first byte from the left hand side. If that is 0, certainly that belong to class A. Okay. Similarly, if the first 2 byte of the first byte is 10, so certainly you can say this is the class B address. If the first 3 byte of the first 3 bit of the first byte of the IP address is 110, then this belong to class C. Similarly, if the first 4 bit of the first byte, that is the 1110, then that belong to class D. And if first 4 bit is 1111 of the first byte, that belong to class E address. Okay, so you should remember this one: 0 class A, 10 class B, 110 class C, 1110 class D, 41 class E. So by looking IP address in binary form, if you have clear idea about this class and their values that is started from, you can easily identify which class this particular IP address belong. Let us see an example. Let us see IP address into binary form. Okay. Suppose a particular address is given like this one. In binary form, this 11001000 first byte, 1 2 3 4 5 6 7 8 bit is there. This is first byte. Dot second byte, we don't care about the second, third and fourth byte. If we have to identify the class of the IP address, we don't care about the second, third and fourth byte. We have to focus only on the first byte. Suppose this is given any value, no problem. Like this one, this one dot, this one. Okay, suppose this is the IP address is given, particular IP address given, and they will ask, tell me the class of this particular IP address. So what you have to do? You have to focus on first byte only and you have to check first sum bit. Okay, so this is the 110. This is the 110. This is the starting from 0. No, so not belong to class A. This is starting from 10. No, 11 is there, not belonging to class B. It is starting from 110. 110, yes. So this belong to class C. 110. Okay. So by using this logic, you can easily check a given address belong to which particular IP, means class. So this is very crucial, no? 0, 1, 0, 1, 1, 0, 1, 1, 0 and all 1. Okay. If binary form is given, you can easily check here. Okay. And if you have no idea, suppose you have only idea about this binary form, you have the trick of binary form only, 0, 1, 0, 1, 1, 0, 1, 1, 0, 4, 1. You have no idea about this binary, which sorry, decimal, suppose. Okay. So no problem. You, if dotted decimal is given, so you can easily convert into binary. You have to convert first byte into binary, and then you can easily check here which class this belong. Suppose I have no idea about this number, no? I have not remember this number. I only know this trick, 0, 1, 0, 1, 1, 0. And suppose we have given a particular IP address like this one. Okay. Suppose 127 dot, okay, 127.10.2.5 is given. And I have asked, please tell me the class of this IP. So I have no idea about this means assignment of the decimal number of the classes, class A, class B, class C. That means I have no idea that class A belongs from 0 to 127 first byte, class B 128 to 191. I have no idea about. I have only idea about this binary. So no problem. Convert this first byte into the binary number. Okay. So what is the binary equivalent of this number? Tell me. 7 1, no? 1 1 1 1 1 1 1. I think this is the 127. 7 1, then 0. 0 7 times 1. So you can easily convert, no? Decimal to binary. And when you convert, you can easily now identify by using this trick. Is it belong? Is it start from 0? Yes. See here. The first bit of the first byte start from 0. That means this certainly this belong to class A. Okay. So this is the logic. You can easily identify in which class this belong. This is important because further when we learn about the subnetting, how to divide a particular network into 4 part or 5 part internally. Suppose AKGC has given a network ID, a network space, and further I want to convert this network into 5 small subnetwork. One for CSC department, one subnet for IT department, one subnet for EC department, one for library, another for account. Okay. So this concept is known as subnetting. So in classful subnetting, you should have clear idea about these classes. Then only further you can subnet, you can divide. Otherwise, you cannot divide. If you have no idea about the classes, you cannot divide. They only give you the IP address and they will say you that please divide this IP addresses, this address, this IP, this network into 2 subnet or into 4 subnet. Okay. So first work will be identification of this IP into class. That's why this is very important. Okay. I think this will be remembered by you, and this is very easy. This number may be not known, remembered by you, but this can be easily remembered. Binary form 0, 1 0, 1 1 0, 1 1 0, 4 times 1. Okay. If starting bit is there, you can easily identify which class this belong. Find the class of each address. Here given the example. This is the first IP address in binary form. So, student, tell me what is the class of this particular IP? Yes? Yes. So, you can easily identify this class, this IP address, the first byte of this IP start from 0. That means this belong to class A. Come back side, see here, class A. First bit 0. This is the second IP address. Tell me, what will be the class of this IP address? Is it start from 0? No, not belong to class A. Is it start from 10? 10? No, not belong to class B. Is it start from 110? Yes. So, this belong to class C. Class C. Here you can easily identify 110. Starting from 110, that means this represents the class C. Okay. Two examples are given in dotted decimal notation. So, this is 14.23.120.8. So, if you have idea about this binary identification of the classes, no problem, you can easily directly find out. This is the 14 come in the range of class A 0 to 127. That's why this belong to class A. Okay. Again 252.5. So, first byte represent the 252. First byte represent 252. Let us check here. So, 252 we can see that this belong to class E. This is lie between the number 240 to 255. So, 252 is here, that belong to class E. That's why this is address belong to class E. Okay. And if you have no idea about this binary, this decimal identification, no problem. What you have to do? You have to convert this into first byte, you have to convert into binary. Binary. What is the binary equivalent of 14? Into 8 bit. This is very important. When you want to convert this first byte, then you have to represent using the 8 bit. How many bit? 8 bit. It may be possible that there is a number 1 here, 1 dot something, and you convert into binary and say this is 1. Is not okay. And you say that this belong to class B or class C that start from 1. No. You have to represent this 14 into 8 bit, into 1 byte. That is very important. After conversion into 1 byte, then you can easily identify. So, convert into 14. We try to write the weight of each and every position of the binary number. This is the first bit LSB 2, 4, 8, 16, 32, 64, 128. Okay. 8 bit is written here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And 14 is there. So, near 14, this is 8. This will be 1. How much weight remain? 6. Near this 4 is set 1. How much remaining? 2. Remaining bit are absent and means 0 value. So, this is the binary conversion into 8 bit of the number 14. 0, 0, 0, 0, 1, 1, 1, 0. So, here we can say that first bit of this byte is 0. That means this belong to class A, like that. Similarly, you have to convert 252 into 8 bit representation into binary. And if this belong, the first 4 bit is 1, 1, 1, 1, that means belong to class E. So, this is very clear. And okay. So, this is the basic concept of the IPv4 addressing format basically. Okay. This is the IPv4 addressing format. IP addressing is a very large topic, and subsequently we will cover one by one. in previous lectures we have covered about what is the network, means a network functionality of the network layer, because this IP protocol work on network layer. What is the IPv4 format, means what is the IPv4 header format, we have seen in previous lectures. We have seen about the IPv4. What is the IPv4 address? What is the IP address? That is the 32-bit long binary string that can be represented into binary, dotted decimal, hexadecimal. Okay. Then in today's lecture we have covered about the different 5 classes that are divided in, means whole address space is divided into 5 parts. Whole address space is divided into 5 parts: class A, class B, class C, class D, class E. So we have seen what are the value of the dotted decimal in first byte in different classes. What are the first binary bit that can identify the class? We have seen, we have solved some example. Okay, that means by seeing the IP address in binary or decimal form, we can now easily identify this IP address belong to which class. Okay, so thanks all. In next lecture we will cover about the subnetting. That is a very important topic of the computer network, and basically we will cover in next class full subnetting. Okay, so we will meet soon in the next lecture. Thank you all.